Every so often, wildfires make headlines, devastating landscape and contributing significantly to the increasing level of CO2. As our world warms, these wildfires become more extreme, making the threat that wildfires already are even bigger. According to the World Economic Forum, human-induced CO2 levels have surged by 50% above the pre-industrial levels. Our planet has warmed by 1.1 degrees Celsius over a century, making hot and dry conditions more common and severe, pushing up the odds of devastating wildfires.
According to the Global Forest Watch, there was an estimated 11.6 million forest fires in Africa in 2023 alone. There has been 1.8 billion, on average, tons of carbon dioxide emitted due to forest fires worldwide. They attribute 20% of all carbon dioxide emissions globally. Kenya itself has recorded 180 fire incidents, out of which 63 were recorded in the Mau Block region. These statistics paint a clear picture of the situation at hand. While the numbers may seem daunting, we believe that our solution is tailored to alleviate these challenges.
So how do we do this? We're collecting data on environmental factors and also fire elements such as carbon dioxide concentration, carbon dioxide concentration, temperature, humidity, and also smoke. Additionally, we integrate thermal imagery to provide rich insights from the fusion of these datasets.
In our first prototype, we have sensors that monitor temperature and humidity, carbon monoxide, carbon dioxide, and infrared radiation. For power, there's a battery pack and a solar panel. And for communication, we have an antenna and a LoRa transceiver that sends data via ground-based LoRaWAN gateway. For our second prototype, we have a battery connector, a solar connector, a charge controller, a microcontroller, and a smaller temperature, humidity, and gas sensor. We have a LoRa transceiver and an antenna connector.
Our second prototype has a small form factor of 3 by 3 centimeters. It leverages microelectromechanical systems, thus consumes about 90% less power than the first prototype. This makes it more energy efficient.
Our web app provides a real-time map of the area with the location of the fire sensors highlighted. This allows firefighters and concerned authorities to quickly identify the location of the fire and plan their response accordingly. The map also displays the sensors' values, such as temperature and smoke levels, which can help firefighters assess the severity of the fire and make informed decisions about how to proceed. On the system, we are able to switch to satellite thermal images to also aid in forest fire identification. In the past, unmanned aerial vehicles, commonly known as UAVs, have been in use in the prevention of forest fires. However, energy constraints due to battery life, limited scope of view, and having their operation affected by adverse weather conditions such as smoke have proven this method to be ineffective to some degree. Our system is advantageous as it offers precise mapping and real-time alerts. Moreover, the monitored parameters can be used to predict the likelihood of fire occurring in the future.
So we are in an era of climate change and loss of biodiversity, and for this we need to adapt and to come up with technologies that will be able to save the climate and also protect the biodiversity. And if with our project we are foreseeing a future whereby all of these will be catered for, and therefore we are providing a better future and a healthier one.